Okay, now we looked at the laws of logarithms, and now what we need to do is to put them together by solving a number of equations. Okay, so these are different elements that we'll see how they actually come together. So our first equation is this. Okay, so remember what we've always learned is that it's whatever you do this side, you also do this side, right? So the only way that I can cancel a log is if I do the opposite of what the log is doing. Normally, if I have got, say, let's say 2x is equal to 3, okay, if I want to liberate my x, I have to do the opposite of what this is doing. So it's multiplying, I have to divide on both sides. So if this is the log of 2, I have to create an exponent of 2 here to reverse this. So what I do is I say 2, okay, then I do log 2x plus 2 equal to, again here I find the exponent of this side. So I've created an exponent here using base of 2. So this is an exponent, that's an exponent. Now what happens, remember that rule where we say that if you have a base and then you raise it to the log of the same base, this reduces to what? This reduces to the value of this. Okay, so this becomes x plus 2 now equal to 2 power 5. So x plus 2 equal to 32. We do the same thing here. We do 32 minus 2. So we get x is equal to 30. Second example is if you had a situation like this, okay, what are we going to do? So we have ln x is equal to 8. Okay, so what do? We are going to look for the opposite of what we are doing here. So remember, this is e, okay, like an e there. So what we do is we put this into that, because that e is silent, and then I do e8 like that. So this gives me what? Reduces to 8 is equal to e8. Okay, so that's the value of x. And what are we going to do here? Again, we have to recognize our patterns. So again, how do we liberate this? Eventually we'll know that if we have this, then it means that to get rid of this, I'll need this base to be the other side. But for now, you really have to show the work that you're doing. So what do I do here? I have to raise both sides to, like you have to have the base of 2. So this is 2. I have to indicate that 2 to make sure that I'm showing what I'm doing. So this is like that. Then this, we say that reduces to this function. And then that becomes 8, right? So I can take x the other side and 8 this side. So 25 minus 8 equal to x. So my x is going to be 17. This is another example. So what do? The first thing that we always have to do is, simplify. So are there like terms that we can work with? We can work with this one and that one. So this 3 log 2x equal to 16. So we'll subtract 4. I'm not going to show all that work. So we have 12, right? So what's the next thing that we can do? Next thing that we can do is we know where this is coming from. It was a power here. Okay, so we need to say log. Actually, I'm not going to reverse it that way. I'm just going to divide by 3. Okay, so this is another pattern. Maybe the easiest. I think I was overthinking. So is equal to 4, right? Then what can I do here? I can raise these two, but remember, they're not telling me what base that is. So it's going to be a base 10. So now, I'm going to raise this to the power of 10, like that. Then here we're going to have 10, okay? And then here we'll have 10 power 4 as well. So what do we have? This one becomes that, because we have that rule that we said if this is like this, log b x, we said that this is x. So this is where all these are coming from. This is why I'm raising it to the same base, because you can see here there's the same base there. And then the value that is returned is x, which is the same. Here we're returning this value here. So that's 10,000 this side. And then I'm going to divide by 2, giving me x equal to 5,000. Okay, here what do we do? Also, we look at the layout, and then we see if we can recognize any of our previous rules or laws. So here I'm recognizing the product rule, which we said was if I have log A and then I have log B, I'm adding these. So we said that these are same as log AB, but the base has to be the same. So we say that these are equal. So it's the same one I'm recognizing here. So I'm going to factor that. Then here I'll have x plus 2, and then I'll have x plus 1. So these are going to multiply just like we have here. And then that would be equal to 1. Now, remember this has no label, so it's going to be log 10. And we said that this is actually going to be an exponent, a base. Since it's a base, if we take it the other side, it will become the opposite of what a log is, which is an exponent. So here, but this maintains its nature as a base, so it will be a base here. So x plus 2, x minus 1 is equal to 10 becomes a base, power 1, so it's 10. Okay, and then now what we're going to do is to expand this, and the expansion of this is x squared minus x, this is plus 2x, then this is minus 2 equals 10. Okay, I think you should be able to remember how we were doing this. So this is plus x minus 2 equal to 10. Now what I'll do is I'll bring this the other side, so I get my eventual equation that I can solve. This is minus 2 minus 10, that's minus 12 equal to 0 now. This already I can see product is minus 12 and the sum is plus 2. Tells me that my situation here will be this and that, because I need a positive here. This is bigger than this one, so it's positive. Okay, so I have x is equal to minus 4 and x will give me plus 3. Those are my solutions. Look at this one. You can pause the video maybe and also just see the patterns that can help you to solve this one. Okay, So from my side, I'm going to concentrate on the base first, check if the bases are the same. If they're the same, then it's almost straightforward. Okay, so I try to see, is there anything that I can easily cancel out to simplify? Okay, here I can't see. So the first thing that I'll do is I'll try and simplify this. So I'll have log 3, 2, I'll keep it like that. Then this, I'll try and take this back in, okay? So this becomes x2 like that. Then is equal to 3, 7x minus 3. Now what I've done here is that I've freed up these logarithms, okay? So that they are just neutral to each other, okay? So here, these had a 2, this one had a 1, and this one had a 1. So now they've all got the same coefficient. So I know that it's easier now for me to combine them. So I can go with the multiplication rule. So this one will be times x squared, because I'm putting these two together. Then here we have log 3, 7, x minus 3. Now, I'm doing the same thing on both sides. So I may as well just not do it, right? So here, it's like that. Then here will be 7x minus 3. Or we can use that law where we put 3 here and put 3 there. Okay, we've seen it in many of the examples that we've done so far. So I put all the terms on one side is equal to 0. I can already see this is 6. To get to minus 7, I will need to have the product of 6, and I'll have a sum of 7, which means that I'll have something like 2x squared minus 6x minus x plus 3 equal to 0. So we can factor this out, and then we get 6. Okay, we get 6. We get 3, not 6. Okay, then here I factor out minus 1. Then we have x minus 3 is equal to 0. Then we have 2x minus 1 will give us x minus 3 is equal to 0. So therefore, our solution set becomes 1 over 2 and 3. So that's our solution set for the values for x. So now, there are times when the bases are not the same. So how do we solve them? Okay, so the key here lies in you choosing a base that works for your whole equation. So I will choose base 2. Okay, so I need to change this into base 2. How do I change it? I can change this into a new base. So this becomes, for example, log 2. Remember, it will take this at first. Then I can also, we also said that this law says that this base 2 gets this value here as the divisor. So that's the change that you can make here. Then we maintain this because we are targeting base 2, like that. Okay, now if I look at this, I can create a power here, so I can do this. Okay, log 2 x. Then here I can do log 2 like that, then 2 power 2. Then I can repeat my statements is equal to 6. So this one here, the 2 comes out, then this whole structure becomes a 1. So I have log 2x over 2 plus log 2x is equal to 6. Right, I can multiply throughout by 2, then I'll get log 2x plus 2 log 2x is equal to 12. So this whole structure here gives me 3 log 2x. So 3 log 2x equal to 12. My 3 goes in there and divides. So I'll divide here. I'll divide here. These cancel. Then I have log 2x equal to 4. Okay. And we say that this goes the other side, it becomes an exponent. So we're saying that now x is equal to 2. So it becomes a base. Okay, so 2 power 4. So we're saying that our x now equal to 16. About this one, what patterns can we see here? Okay, you can even pause the video and see the patterns. So here, I'm going to focus on the base 3. Okay, so what do? I try and make sure that my bases are the same. So how do I do that? The first thing that I need to do is that this is already in my preferred base, so I leave it just the way it is. And in this one, I make sure that I split this into 2 bases. And we say that if you have this one, maybe A, B, that will give you, in a new base, that will give you, let's say this is C, it will give you B here, and then there it will give you log C, A, like that. So it's upon this premise that I will try and split this. So I'll try and use my base 3 here. Okay, so I start off with my 4. Then here I do my log 9, 3, and then 9. Okay, so this is going to repeat. And then what do I have here? I cannot change anything here at the moment, so I'll repeat it. But for this one, I think I can. So I'll square this. So this will become 3 power 3. I focus on that same area because I know I can still do something here. So I'll say this. And then what else can I say? I can bring this outside the log function. And then we have this. So this we know is 1. We looked at this where we said if you have log A, we said that this gives 1. Okay. So we know this is 1 and then this is 2. So the 2 goes this side. So I have 2 log 3x equal to log 3, 4. Now I'm continuing from here. Now here I can make sure that this goes inside here. So I'll have log 3x squared equal to log 3, 4. Now we know that log is a singular function, so whatever you have, the input here has to equal, okay? Or we can use some other rules and then still get to the same answer. So I'll use the simple one. I'll just equate x squared equal to 4. Then we said that we can find square roots of these. So we have x is equal to minus 2 and x is equal to 2. like that. Okay, but you'll have to check to see whether this works, because if I brought it here, it will not work. So your solution set now becomes just 2, because negative will not work here. Okay.